Okay. So you have to find out all these things from the first block itself. It is going to find out the capital E and V and C later on applications of the C. Okay, that is the case. Whereas in block 2, uh, current electricity. Okay, so here you may find out the what is the electrical conductivity value, uh, and Kirchhoff laws and Networks theorem, Thevenin theorem, Norton theorem, superposition theorem, maximum power transformation theorem, reciprocity theorem. All these theorems which comes under the Networks theorems. And above that, Kirchhoff's current law, KCL as well as the KVL is also there. Kirchhoff's current law and Kirchhoff's voltage law. And before that, that is electrical conductivity. Okay. So what is the drift velocity value? Everything comes under the electrical current. Next, whereas in the block 3, this is the different than the first two. Okay. Here you can able to find out the magnetostatics. From the magnetostatics, you have to find out the B value. B is nothing but a magnetic field, strength of the magnetic field, or else you have to say that magnetic induction, capital B. First unit is capital E and third unit is the capital B. Okay. So Ampere's law, line integral B dot dl equals to mu naught I. There itself you have to apply this some applications to the Ampere's law. Later on Biot-Savart's law. Okay. dB equals to mu naught by 4 pi into ideal sin theta by r square. So there itself by using that Biot-Savart's law also you need to find out the some applications. Based on that applications, you have to calculate the capital B value. Okay. So third one is the magnetic field and magnetic force on your circuit, torque tau value. Okay. IBL sin theta. That is a value you need to find out here. Torque tau value. These are the conditions. Okay. And whereas the fourth block, which may have electromagnetic induction. Here itself, you need to calculate the what is the self-inductance and L value and mutual inductance, capital M value. Okay. And also phi B value. Uh, and Faraday's law, you know pretty well. E dot dl equals to minus dou phi B by dou t. And Lenz law. Okay. So this is the case. So this is entire related to the electromagnetic induction. Okay. Electromagnetism, electricity is there concepts and magnetism concepts are there, and electromagnetic induction is also there. So before going to discuss, shall we go for the electrostatics? In this electrostatics, first of all, we can go for the point charges. uh, I will go for the whiteboard here. First of all, what are plus q and minus q? Positive point charge. This is the negative point charge. Okay. So here the what are these? These are the line of force of field. These. This is denoted by capital F. In the case of positive charge, you may observe the line of force of field which are in outward. Whereas the line of force of field for the negative charge is inward. Okay. So here F is there, Q is there. The ratio of the magnitude of the charge to the force is nothing but a intensity of the electric field. F equals to QE or F by Q equals to E. So you may observe that what do you mean by electric field? Intensity of the electric field, which may be defined that here. How much of the effect of the charge which can be occupied by such a region. Okay. So that you can call it as a electric field. So here also if you consider the magnetic field means here magnetic field property which is nothing but which is going to be attracting the lightweight bodies. So that the attraction power, how much of the occupied by this attraction which can be occupied by such a region, you can call it as a magnetic field. There itself in terms of the magnetic field you can tell that. But here in terms of the electric field, how we are going to be defining that here? The charge is there, whether it is a positive or negative charge, whatever it may be here, the effect of the positive charge which can be occupied by such a region, ఎంత మేర ప్రాంతం ఆవరించి ఉంటుందో, then you can call it as a electric field. So that whenever a point charge is there, the line of force of field should be there. Okay. Based on the signs of the that is whether it is positive or negative, whatever it may be here, the arrows which are to be indicating here where it is a positive and which is a negative means you can easily estimate by arrow mark. So the thing is that here positive charge is there, line of force of field is there. If line of force of field as well as the positive charge both are present, electric field is there. Why? Because of the ratio of the magnitude of the force to the charge, which is nothing but a electric field, intensity of the electric field. What is the formula for the units for the electric field? F by Q and E. Force which is in newtons, which is in coulomb. So electric field for units are N by C. Newton per coulomb. Okay. So these are the units. So the thing is that you need to go for this here. What is electric field? We derived the definition. The charge which can be occupied by such a region, you can call it as electric field. The ratio of the magnitude of the force to the charge is nothing but I'll say intensity of the electric field. For the units are which are given out here. And if a positive charge is there, negative charge is there, how the line of force of field which are going to be representing, you can easily observe that. And if charge is there, line of force of field is there, both are present, there is a electric. This is the case. But next is the Coulomb's law. We can go for this. Coulomb's law, what it states? Coulomb's law. Hey. If positive charge is there, negative charge is there, both the charges which are to be separated by a distance smaller, then the force of attraction or repulsion, which is always proportional to the product of their magnitude of the charges. Let you say this is the first one, this is the second charge. And also inversely proportional to the square of the distance between them. By combining this equation, what is the proportionality constant? Okay. So this may be written as, let us assume that this point charge which is at infinity distance, or else by the intensity of the magnetic field. Is it clear? What is F by Q? Capital E. What is capital E? Intensity of the electric field. What are the units? Newton per coulomb. So that how you are going to write this electric field equation? This is the equation. Okay. So I just want to share a screen. So what do you mean by electric flux? So in this electric flux, we can define that here. Yeah. So which is to be denoted by here. So electric flux, which is always denoted by phi E. So the formula, which is surface integral E dot ds. Okay. So you can imagine that here how the this arrow marks, you can go through this. All which are in outwards. Okay. You can see. So here you have to imagine that a plus Q charge is there. What is that? Plus Q charge. Whenever a plus Q charge is there, line of force of field which is outwards, it can be easily tell that here the line of force of field, all these are arrow marks. What are these line of force? How it comes? There is a positive charge. F by Q intensity. This is the case. Okay. So what is this here? A closed surface is to be imagined in the direction of the electric line of force of field. So how we are defining this electric flux means the electric flux by E through a surface which is placed here. Which is one? This is the surface which you placed inside the electric field. Then the total number of electric lines force which are crossing the surface and which is in a direction normal to the surface. Then you have to say that that is nothing but a electric flux. So this is denoted by like this. That means E integral ds E dot. But what is E dot E? You know that two vectors are there. Dot product where theta is the angle between these two, E and A. Okay. So this is the case. Next, you can go for the uh, electric flux through other surfaces. If it is going to be measures the number of field lines which are passing through this surface, here there is a flux which is present here. Why? Because of both E and ds both are parallel to each other. But here E which is in this direction, surface which is in this direction, both there is a perpendicular direction 90 degrees. So in this case, you may have ds which can gives you ds cos 90 degrees. Cos 90 is 0. So that means here there is no flux at all. No flux. Is it okay? Next. Here flux which may depends upon the orientation. How the electric flux which may depends upon the orientation. If the surface which is to be considered inside the line of force here, if it is going to be moving in different directions and it is to be making with the different angles here with the direction of the line of force of field. So here you can easily say that how the flux value which is to be depends upon. So that the number of field lines which are to be passing through the surface area which is equals to the number of which is uh, through its projection, so that the flux value uh, which is to be projected in like this. Here you can easily project this. What is the flux value here also? So if the surface which is in the shape of a curved shape, how you are going to find out the flux value for this curved surface? There itself, you can see this is the curved one. What is A? A is the area of this surface. So on this surface, if you consider a small area, that area which is to be occupied, the area is dA or ds, whatever it may be. The thing is that here the line of force of field which is E, and the angle between the dA and E is theta. So definitely there is a flux value phi E. Okay. So that here the surface which may be divided into in a small regions, there itself that area which should be a dA. So the what is the flux there? D phi equals to EDA cos theta. That is EDA. Okay. So if you want to get the total flux here, by integrating this, you may get the what is the flux there. Like that. So in a closed surface is also. Only that. In a closed surface also, you can easily find out that the flux value, which is representing here, uh, phi value, which is nothing but integral d phi. Integral d phi is nothing but a phi. What is phi value? According to the definition, E dot ds or else E dot dA. Okay. The loop means integral which is over a closed surface. This is the closed surface. So this is the case. For a closed surface. Okay, if it is the flux which is positive for if it is leaving out from the closed one, that is positive. If it is entering into the closed one, that should be considered as a negative. Okay, always you should remember here. That means whenever a closed surface which may be occupied by such a volume, if it is to be considered like that, there itself, if you want to calculate the flux value, you have to divide it into two or three or four, whatever it may be here, different categories, where the flux is entering and where the flux is going to be leaving out from that particular closed wall area. You can easily substitute these. The one, if it is entering means flux is negative, if it is coming out from that particular other point is positive. So that total entire flux through the throughout the entire closed surface, which is to be considered that the summation of these points. That means it becomes a zero. Why? Because of at some point it is entering and at the other point it is leaving out. Means for the any closed surface, uh, the flux value which should becomes always zero. Okay. Next is the gas line electrostatics. This is the very, very important one. Gas line electrostatics, which is stating that the normal electric flux over any closed surface. Okay. The normal electric flux over any closed surface, which is always equals to the 1 by epsilon naught times. What do you mean by epsilon naught? Epsilon naught is the permittivity of the free space. If naught is there, that is a free space. If naught is not there, there should be a medium is present. There itself, it is not to be denoting that epsilon naught. You should write it down that epsilon. Okay. So here, the normal electric flux over any closed surface, which is equals to the 1 by epsilon naught times the total charge enclosed within the surface. Total charge which is enclosed in the surface. So that is the statement for the Gauss law. But our aim is that you need to prove that statement. First of all, write it down the statement in the form of equation. Later on, you have to prove. Okay, Randy? So here the statement which is indicating that the normal electric flux. So here this one. Welcome. Normal electric flux, which is denoted by phi e. What is the formula for the phi e? Surface integral E dot ds, which is always equals to normal electric flux over any closed surface. Closed surface, this one. This is indicating the closed surface. Yes, surface integral E dot ds, which is equals to 1 by epsilon naught times. Times means multiplication of the total charge, capital Q, of the total charge, capital Q, within the surface. So that you may be written as here phi equals to Q by epsilon. Whatever it may be, if it is a small q or capital Q, whatever it may be, the thing is that here you need to uh, imagine that whether it is a point charge or the total charge which may be occupied. Capital Q, which is nothing but a summation of the all the point charges which are present inside Q1, Q2, Q3, and so on. That is capital Q. Okay. So here you need to find out you need to prove that flux phi is nothing but a Q by epsilon. This is the Gauss law. But according to the definition, phi is nothing but a surface integral E dot ds. This is the definition. So this must be equals to this one. So that for this case, phi is nothing but a d phi integral. But you know pretty well integral d phi is nothing but E dot ds. Dot product E dot ds is EDA cos theta. But you know from the Coulomb's law, what is E value? 1 by 4 pi epsilon naught into Q by R square. This is the case. dA is there. Both are parallel here. Here. That means this is the closed surface. There is a point charge at a distance smaller. If you consider a point, that point is to be occupied by the area as dA. There itself, from the point, the line of force of field which are crossing here. Both ds as well as the line of force of field parallel to each other. That means here theta should be 0. That cos theta, cos 0 is 1. So that what is the flux at point P due to the point charge Q? This one. E dot E. Getting my point? How do you return this means from this figure itself? So, but the thing is that dA by R square is which is always nothing but a d omega. D omega is nothing but here the space is occupied by this one. Conic section. This. If you consider the point should be like this. So this is the conic section. If you imagine, this is the d omega value. D omega by R, at what distance the point is chosen? Let you imagine P is there. P occupied by the area is dA. What distance? Small r distance. dA by R square, which is a d omega. Solid angle. Integral d omega is nothing but a 4 pi. 4 pi, 4 pi get cancelled. Remaining is Q by epsilon. Okay. So most important. So the electric flux through any closed surface, which is equals to the charge by epsilon naught. Okay. Total charge which is enclosed within the surface. Charge by epsilon naught. Charge means inside charge, not outside. Q by epsilon naught. So this is always true. Here occasionally it may provides that a very easy way to find the electric field. Okay. That means if you consider one of the application is a sphere which may have a positive charge, the radius is smaller there itself. If you want to calculate the capital E value, that is also from by using the gas line electrostatics, you can easily find out. Or else, if it is a infiniting uh, uh, conducting sheet is there itself, if you want to calculate the capital E value, sigma by epsilon. Okay. And also cylindrical form. Different applications are there. You have to implement easily to calculate the capital E value. Basement is that gas law. From that gas law, you can easily find out E values. All these are related to the static charges. Okay. Static means it is not varying with respect to time. So you can see, calculate the electric field which is produced by a point charge using the gas law. By choosing the Gaussian surface a sphere of radius small r, centered on the charge is capital Q. That is a positive charge. That means the line of force of field which is an outwards. So that there should be electric field which have the same magnitude everywhere on the surface. Okay. But at each point on the surface, the electric field and the surface both are normal. dA, normal dA which is parallel together. There itself, E dot dA means EDA cos theta, theta value 0. Why? Because of both are parallel. Then you have to say that EDA. Next, electric field produced by a point charge. See here. So here E dot ds equals to Q by epsilon naught, or E dot ds is EDA or EA. What is the area of this sphere? And if the radius is capital R or small r, okay. If it is small r, radius is small r, there itself, what is the area of this sphere? 4 pi r square. What is the volume? And 4 by 3 pi r cube. Okay. So here in place of EA, E dot A, E dot A means 4 pi r square, which is equals to Gauss law. What is it is going to be stating here? Q by epsilon naught. So that if 4 pi r square, if it is going in right side, which may have E equals to 1 by 4 pi epsilon naught into Q by r square. What it is? Electric field value. Okay. Electric field value. So that here 1 by 4 pi epsilon naught, if you consider it as a k q by r square. Epsilon naught is the permittivity, epsilon naught value 8.85, approximately 9. 9 into 10 power minus 12. Coulomb square per Newton meter square. Okay. So this is the case. Only the thing is that from the Gauss law itself, you have been derived the Coulomb's law. Okay. What is the differential form of the Gauss law? So differential form means according to Gauss law, E dot ds equals to q by epsilon naught, or else epsilon naught surface integral E dot ds equals to q. So this is about the Gauss law. Let us assume that a point charge plus q, which is distributed over the uniformly over a volume V. Then what is the charge density? Rho equals to q by V. Rho equals to q by V. This implies q equals to rho V, or q equals to volume integral rho dV. Okay. So this is the case. So you can substitute here. Epsilon naught surface integral E dot ds equals to volume integral rho dV. Left side is surface, right side is volume. So that if you want to convert Gauss divergence theorem, okay? Yeah. So this may be written as volume integral divergence E T. Okay? So that therefore epsilon naught volume integral divergence E dV equals to volume integral rho. Both are volumes, so that divergence means del dot E rho. So divergence E equals to rho by epsilon. So divergence E equals to rho by epsilon naught, or del dot E equals to rho by epsilon naught, or epsilon naught into del dot E equals to rho, or del dot epsilon naught E equals to rho, or del dot D equals to rho, or divergence D equals to rho. Divergence D rho, divergence E rho by epsilon. Most important. Okay. These are the differential form of the Gauss. Okay. What is the integral form of the Gauss law? This one is the integral form. This one. This is the integral form. Surface integral E dot is equals to q by epsilon naught. Differential form divergence D equals to rho. What do you mean by D? Displacement current. D is nothing but a displacement current. Okay. We can go through this. So electric field due to an infinitely long charge distribution. This is an electric field due to an infinite conducting sheet of charge. Here the application, one of the best application. Gauss law, which is useful only when the electric field is constant, not the givens. So this is a infinite sheet of charge. This is the sheet of charge. What it contains? Positive charge. If positive charge is there, line of force of field outwards. Backside, line of force of field outward. Here also. If positive charge Q is there, line of force of field F is there, what it is? Capital E is there. That means if E is there, definitely flux is there. What is the charge density on the surface? Okay. Sigma equals to, in previously, volume density. Okay. That is rho equals to Q by V. Here the sigma is Q by A or Q by S surface. So here it is denoting Q equals to sigma S. అర్థమవుతుందండి? S ప్లేస్ లో లేకపోతే ఇక్కడ దీన్ని మనం సిగ్మా ఈక్వల్స్ టు Q ఈక్వల్స్ టు. So if you want to calculate the electric field value due to this infinite sheet of charge, first of all, you have to imagine a Gaussian surface, which is in the form of cylindrical shape. So here 3 points are to be chosen. One is right side, another one is the left side, and the third one is the on the surface. This is 1, 2, 3. Okay. So which is in the form of cylindrical means here itself, if you imagine a point that is surface is in upward direction, point is which is in occupied the area is in this. That means line of force of field which is in this direction, surface in this direction. What is the angle? 90 degrees. Is any flux is there? No flux. Left side is also no flux. Only the contribution of the flux which resides on the surface of the sheet. Okay. So here you may have both are parallel to each other. Why? Because of surface as well as the line of force of field, both are in parallel direction. There itself the electric flux value is this. So according to the Gaussian surface, uh, by using the Gaussian surface, which is in the form of cylindrical pillbox, by calculating the flux of the electric field strength through the Gaussian surface, which may gives you 2E, or by equating the phi value Q by epsilon naught by using the Gaussian's Gauss law, 2E is Q by epsilon naught, or else Q by 2A. So that what do you mean by Q by A? Sigma by 2 epsilon. So what is the electric field due to an infinite sheet of charge by using the Gauss law? Sigma by 2 epsilon. Okay. Sigma by 2 epsilon. Here you can see here the problems also given out. Intensity of the electron. So here the intensity of the electric field, which is always already find out here, E value, how to calculate the E value. The ratio of the magnitude of the force to the charge is nothing but intensity of the electric field, E value. That was already calculated. And just now we discussed this. Intensity of the electric field on the surface of the charged conductor. by using the Coulomb's theorem. You can imagine that here. What it is stating here. Here. You can see. There is a line of force of point charge is there. On the surface, if it is the charge which is uniformly distributed over this sheet here, there itself, if you want to calculate the E means it is impossible. But the thing is that here by imagining a Gaussian surface, which is in the form of cylindrical, okay, there itself, this is the right side, this is the left side, this is on the surface. Three cases. Here left, right, surface. Surface is in this direction, line of force against. Both are perpendicular. Here also perpendicular. Only the contribution of the flux which resides on the surface of the sheet. Okay. So you can easily calculate this, which is going to be stating the Coulomb's law. Sigma by epsilon naught. Line of force of it. So you can go for this. This is a positive charge. Positive charge. This is outward. Arrow marks you can see here, which are always in outward. See here, one is a negative charge, another one is a positive charge. Positive charge outwards, going out. Negative charge inwards. So that there is attraction between them. Okay. So unlike charges, they may attract each other. But here you can see this is the positive, this is also positive. Like charges, repulsion is going to be takes place between them. Both are repelled with each other. Okay. Repulsion is to be takes place. This is a positive charge, first figure. Second figure is the unlike charges, they may attract each other. This is the third figure. This is indicating here like charges which may repel each other. With respect to the figures, you need to project. This is already discussed. Electric flux. So you have to imagine that positive charge. Sir, why it is positive charge? You can see the arrow marks outward. Outward means positive. So in this, if you imagine a closed surface, the surface which may be divided into a number of infinitesimal areas. Infinitesimal areas which are this one, here, this one, this one. This is indicating to this one is indicating this one is indicating this. Okay. Infinitesimal area is delta S, approximately ds, which is nothing but a dA. Okay. Integral ds is A, area occupied by the closed surface. So that how many number of force of lines which are crossing the unit area, unit surface area, and that direction which is normal to it, then you have to say that there is a flux. Okay. These lines which are perpendicular, normal to it, then there is a flux. Next, electric displacement dU. Okay. So the charge displaced per unit area, which is perpendicular to the electric field, which may gives the amount of the displacement and which is represented by capital D. Formula is epsilon naught. Dielectric constant. Epsilon may be K epsilon naught. This is the Gauss theorem. So a little bit you should know that Carl Friedrich Gauss is the director of the Gottingen Observatory made outstanding contribution to the different fields. What are those? Astronomy, mathematics, electricity, magnetism. Okay. So here the Gauss theorem, which enables to determine uh, the intensity of electric field at any point on the closed surface. So if the charge which is placed inside the surface, which is unknown known here, and the charge producing the field can be determined charge inside the surface. Similarly, which is to be produced in the field can be determined, the intensity known, and the theorem which is going to be stating that the total normal electrical induction or else electric flux over any closed surface which is the shape drawn in the electric field, which is 4 pi times of the total charge. Total charge means the algebraical sum of the charges within the surface. You just now proved this theorem also. And also you define the what is the differential form. Applications of the Gauss law. Deriving the law from the Coulomb's law uh, and application of Gauss law intensity of uniformly charged sphere. Uniformly charged sphere. You can easily identify this. One figure it tells that, see here, this is the sphere here of radius is capital R. Radius of the R. O is the origin. There is a plus charge due to this line of force of friction. Here, this is the outside. This is the inside. This is the R. Okay. Outside sphere point is P. Inside is P dash. This is the outside sphere B. Inside this one. What is the distance, the point which is chosen from the outside? Small r. Inside is r dash. Okay. On the surface itself it is. Okay, Andy? Three cases. But you need to tell that what is the intensity of the electric field when the point is to be chosen outside or inside on the sphere, how the electric field value is changing. If you choose outside, the electric field value which is inversely proportional to the square of the distance on the sphere it remains constant. Inside, from the point towards the surface, the intensity of the electric field is gradually increasing. With respect to the graphical representation, you need to project this. Okay. So that E values always outside, decreasing, inside. You see here the calculation part. You can go through this. Inside toward the point of the surface increasing. On the surface it remains same. State the Gauss theorem and applications. Intensity of the electric field uniformly charges. Expected essay question. Coulomb's law from Gauss law. Okay. So this ends our first chapter. Quickly we can go for the second in coming class. Okay, right. Thank you.